Hello folks, we were just preparing for the Vintage Computer Festival and we thought it would be a good idea to record a full organized demo of the Alto, which we have never done up to now. So Ken and I are going to get you through a little tour of the Alto.
Okay, the first step is to reboot the Alto from the hard disk. There's a red button on the back here.
And that's the magic button we were pressing all the time during the restoration until it finally booted. Okay, I see the red button.
Okay, so I push the red button and that will cause the computer to boot from the hard disk.
And one of the surprising thing, I expected it to come up with a GUI, but it really doesn't, right?
That's right, the system comes up with a very simple command line interface. For instance, if we hit a question mark, we can list the files that are stored on this 2.5 megabyte disk.
Right.
We're going to start with Neptune. Now Neptune is a more graphical file browser.
Right.
It's kind of a finder program. It lists the files that are on the disk. And if you have two disks, it'll list the files on both disks. And this is a mouse-based program, so you can click files you want moved to a different disk. You can use the right click to click files you want to delete. Notice that the cursor changes shape as I move from place to place. If I move off to the left here, it turns into a scrollbar control. And this scrollbar is not like modern scrollbars. It's a little trickier to use. The left button will scroll up, and the right mouse button will scroll down. So it's not like a modern scrollbar where you can just drag the slider to get to where you want to go. Another thing in the Neptune file browser is you can view a file by typing out its contents. So for instance, we can look at a log file here and type out what's in the file from right inside here. But unlike a modern Finder, you can't start programs from here.
So you can't launch anything from the browser, right?
Right, you have to go back to the command line. So next I'll start the Bravo text editor. Okay, first I'll load a file by pressing the G key, G for get. You can see the status bar updates, and now I type in the file name. And the file loads off disk.
So there's no menus at all in Bravo, right? It's all command based. Well, key type based. You type a command key.
You can see that Bravo has a variety of different fonts. You can have things in bold. You can have things in italics. You can have your justified text with nice margins. You can center text. You've got fancy fonts like Old English. It even has a mathematical font. So
yeah, and the smiley face. I was blown away by the smiley face. And
right, one of the fonts includes a smiley face and pointing fingers.
Yeah.
So you could almost think of this as early emojis. So editing is a bit different from what you'd expect in an editor, but we left click to select text, and then we right click to select the end of the text, and that's how we highlight a region, which you can see is now underlined.
Okay.
So if we want to change the way it looks, for instance, change the font, we hit L for look, and now the command line is updated with different options we can have for the look. B for bold, I for italic, different font numbers 0 through 9, C for center, J for justify, and so forth. So for instance, if we hit B, our selected text is now in bold.
Can you change the font also?
So if we go back to L, we can choose a different font, and now we have that text in Old English.
Right, cool. Cut and paste, right?
So we can select text. Again, we click with the left mouse button and the right mouse button. Now to cut and paste, first we hit D for delete, and that cuts the text. Now we can move the mouse to where we want to put the text and hit I for insert, and then escape. And now you can see the text that we cut and paste has been moved up
all the concepts of the modern text editor are in here in 1970, what, 4, 5, 6?
Yeah.
Like it was made by the same guy that eventually did Word at Microsoft.
Right. The nice thing is that once you have your text here, you can print it out on a high-resolution laser printer. Xerox invented the laser printer in this time frame, hooked it up to a network, so you could send this file and have it printed out in high resolution. In fact, Xerox used this for the documentation for the Alto.
Yeah.
So they would print out manuals that were written in Bravo.
And Ken, that's the user manual that was donated to us by Xerox, actually. So next up, we are going to do the Draw program, right?
And you'll see that Draw has a very different user interface from Bravo. Draw has icons you can click on.
However, the icons look familiar, but the way you work is not quite exactly what you'd expect. So you can see that it's still experimental.
So to do something, you have to first select the option, then select some points, and then make the operation happen. Up here, you have different brushes you can pick, brush shape and then line width. So then down here, you have different functions. So this one will draw a closed curve. So what we do is we put down some points using the mouse, and then we click the paintbrush, and it draws a nice spline curve through those points. So we can draw more curves by clicking and then using the paintbrush.
And Ken is an amazing draw artist.
So we can draw a few more points here. And we can draw a more complex curve by putting in multiple points. So it allows you to make high resolution drawings that you can then print out on a laser printer. And so Draw was used for many of the drawings in the documentation. So we can finish our drawing here. If you want to modify it, it's a little strange. The square box here allows you to select something, and then if you click on it, all you just know that it's selected is this little square highlight. So now we could select a different line width, and then use the paintbrush to redraw that line. And now it gets drawn as a thin line.
Cool.
There's a scissors operation here, which you might think will cut or delete.
It does
but
not.
surprisingly, it turns the line into a dotted line.
Yeah, I did that too. I wanted to cut and I didn't do it at all.
So it has functions for moving and copying. A simple move operation, you select the item and then you click 2 points. These 2 points define a vector and your curve is moved along that vector. So one advantage of that user interface is that you can do arbitrary scales and transformations. So if I click the triangle transformation, now what I do is I define 3 points of a triangle, and now I define 3 points of a new triangle, and the curve is scaled according to that transformation. So you can rotate, you can stretch, you can shear. So you also have support for text. Now I can type some text at the bottom, and I click on that text, and then I can drop the text onto the picture wherever I want.
Cool. And next one we are going to do SIL.
Right.
Simple Illustrator, which is nothing but simple. Actually, that's almost a full-fledged CAD program.
And you'll notice that it's very different from Draw. You have no icons, you have to know all the commands. All you have is a status line at the top. So left click, right click, and then Control V gives us a box. We can use the middle mouse button to draw some lines. We can draw some thicker lines if we want.
So Ken has become the expert of this thing. How many hours of studying the manual did you have to do for that one?
It's not very intuitive.
Right.
So there's several macro files defined. So for instance, if I hit an A, for the macro will then be activated and draw a complex gate. So next I'll show one of the complex documents that Xerox built using this system. It takes a few moments to load here.
It takes a while, but the result is worth waiting for.
So you can see a very complex page has been built with SIL, and then you can print this out at high resolution.
And that's kind of a data sheet or something.
Right.
That's totally amazing. And we found also the original drawings for the architecture of the machine on there.
So I will load one of the figures from the hardware diagram.
Right, and
this diagram explains the processor architecture of the Alto. So this diagram in the hardware manual has been very helpful to us, and here we have the original source of that diagram.
Right, so if you guys have seen this in the first few sessions, we before the machine even boots, we start using this diagram, and in the end, the machine gives it back to us. Excellent.
Okay, so I'm going to load the Smalltalk disk into the drive and start it up. Now it takes about a minute to load because it first blows filtered air across the disk surface to clean off any dust, and then once the surface is clean, then it will drop the heads down. Okay, so I will start up Smalltalk. And so now what you see in Smalltalk is much more like a modern desktop environment where you have overlapping windows. One thing that's missing from here is the icons that you find on a modern desktop.
Right.
Though the Windows icons weren't introduced yet.
Right, but that's actually the only program that we found so far that has overlapping windows, right?
Right. So if we click on a window, that window moves to the front and gets redrawn. And if we click on another window, that window moves to the front and gets redrawn. For instance, if we want to move a window, we hold down the right mouse button and we get a pop-up menu here. I'm going to select frame, which will let us move the window. So now we drag and drop, basically rubber banding for the new window location.
It's redrawn, but
And now what's interesting here is that the other window did not get redrawn.
right, only when you click on it, it will
windows
come
in
back
the
to
background are like totally not in action.
life. Right.
And
Okay.
now over here you can see the scroll bar better.
Yeah.
If we move into the box, we can drag the box to position in the document we want. For scrolling up and down, it's a little strange by modern perspectives. If you're on the left-hand side of the scroll bar, you get a down arrow and you scroll down. On the right-hand side, it changes into an up arrow and it will scroll up.
Uh-huh.
And you can see on the menu that you have things like copy, cut, and paste, modern commands.
Right.
You also have undo option, so there's undo support, cancel. Smalltalk is object-oriented and everything in Smalltalk is an object. Smalltalk also is reflective, so you can look inside it and see all the classes while the system is running. So I'll click on the class browser here to bring it to the front. And you see categories of classes. For instance, I can click on basic data structures. And over here it brings up all your array, queue, sets, string, and so forth. You can then drill down into these and see the actual source code. So for instance, if I go to panes and menus here, we now see the different types of things, including Scrollbar. So if I click on Scrollbar, it now has the categories of methods. And now if I want to see the show method, I can click on it and it brings up the source code for the Scrollbar show. So this is Smalltalk code that handles the Scrollbar.
And then you can even modify it on the fly.
That's one of the amazing features of Smalltalk. If I don't like the way the Scrollbar works, I can just change it. So currently it has clear for a white background. So if I change this to light gray, now I can middle click to bring up the menu and select compile. And now it will recompile that code while the system is still running. And there you can see the Scrollbar now appears with a gray background. And if we go to a different window, you'll see that window also has the Scrollbar now with a gray background.
Right.
So we've changed the way the user interface is implemented while the system is running.
Right, which is pretty impressive.
So this is something that Smalltalk could do back in the 70s, but you can't really do with a modern system.
Right. Cool.
So Xerox invented the Ethernet as part of the Alto project, providing most of the network features you'd like, such as remote files, email. And one interesting thing is being able to boot off the network. So even though our disk is not mounted here, you can hold down a couple of keys and press the reset button, and now the system will boot from our server across the network. So it's loading across the network, and here it's come up with the network executive, which was loaded from the network without using this disk.
Right.
You can also reinstall your system across the network.
And by the way, the network we are using is this modern computer here with an FPGA card to talk to this non-standard 3 megabit Ethernet network, and has been loaned to us by the Living Computer Museum.
You can log errors over the network. It's very flexible. Now to continue, I want to load the disk again. So I can load the FTP program itself across the network. And here we have a FTP window. So now I can type commands into this window. So I can log in as the test user. And now I'll open the connection to host 1, which is our PC file server. And you can see it's established a connection. And now I can say list, and list the files that are stored on the remote disk, on the remote server. And now I can retrieve one of these files. For instance, a VCPL program. And after just a second, it's now downloaded that program across the network onto the local disk here. This application also has a telnet window at the bottom here that allowed you to telnet to a different computer on the network and execute commands there. I've set up our gateway so you can telnet to a remote computer on today's internet. So for instance, if we put in google.com, it will now connect to Google and download the HTML for the home page.
Yeah, so our 1970s computer just went out to the 2017 world.
I haven't implemented a full browser yet, so it just displays the raw HTML rather than a nice page.
Yeah, we're all waiting for that. Also, that'll be hard to get the browser working on a machine like this. Browsers are very CPU intensive.
One of the fun things about the Alto is people wrote a lot of games for it. So I'm going to start with a pinball game. Type in pinball here and load it. And so it draws a pinball here, pinball field here. And now we can hold down S to launch the ball. You can see the ball going here. We have a simple physics engine to move the ball. And the shift keys control the paddles. So, oh, looks like I just lost that ball. Too bad.
Okay. Very nice program. Beautifully drawn.
so this is basically the arcade game that allows you to control a spaceship, fly around, and shoot at the various asteroids that are coming your way and break them up into smaller pieces.
Yeah, this game is one of the most responsive ones of the bunch. And that's all, of course, micro-coded, so you have to boot straight in the game. Again.
So let's boot this up. And so this is basically Space Invaders themed.
Yeah, Ayatollah at the top.
Ayatollah at the top, attacking American flags. And here you have oil wells, gushing oil, pumping oil derricks, and OPEC, and then a mushroom cloud when you die. So,
and it's dropping bombs on the American flag.
And this game is controlled through the mouse.
Oh yeah, with nice explosion. Poof.
So I'm not entirely sure what the political message is here, but it shows that it's a 1970s era system.
Definitely.
And you can see this was written by Avi Tevenian, who later became CTO of Apple.
Right. It's when he was very early in his career at University of Rochester, which actually he says in his oral history that he chose that over other universities because he had seen an Alto there. Yeah, and then he made a Mac version of this later on, which has also gotten pretty famous. And then he made the Mac OS, eventually OS 10, OS X, right? That's his big contribution to today's world. What we've done so far was historical, but Ken also wrote some new programs the old way on the Alto.
So I've written some programs in BCPL, which is a language that was the ancestor of C. So the first program here shows the graphics quality of the Xerox Alto. It's basically a self-portrait.
The Alto showing the Alto, showing the Alto, showing the Alto. Yeah, very clever, Mr. Ken.
Next, I wanted to do something totally anachronistic by seeing if the Alto could mine Bitcoin. So I implemented the Bitcoin SHA-256 hash algorithm.
Right, and that's the second time you do this. You did it on the IBM 1401 from the 1960s.
So this is a much faster machine.
Yeah, so this is a giant leap into the future.
So it can do about a couple hashes a second compared to modern hardware, which does billions of hashes a second. And so basically it will keep trying to hash Bitcoin records until it finds a successful hash. So, and here we go. It found a successful hash, as you can tell from all the zeros here. Unfortunately, this doesn't make me any money because I started it near a known hash, because otherwise it would take more than the end of the universe to find a successful Bitcoin.
Gives you an idea on how the speed differential, right, in the billion, right, definitely,
yeah.
Right. It's just.
And then the final program I wrote was a Mandelbrot set generator. It's relatively slow. It takes about 9 minutes to render the full Mandelbrot set. You can see here bits of it slowly appearing as it goes through the algorithm. Okay, well, that's the end of our demonstration. You've seen some of the old Alto software and some new programs we've written. You've seen the networking, and I hope you've enjoyed this. Thank you.